Okay, now as our circuits start to get a little bit more complex, we're going to add in another element. In this case, we're going to add this 3-volt vibration motor, and it often gets found in massage chairs and other types of objects that need to sort of have that simulation of a vibration. A smaller version of this would be in your phone, for example. That's what creates that vibrate setting. So what we're going to do is we're going to hook it up in series. So I'm always mindful. I want to make sure that I have a path for the electrons to go all the way through. So I have opened up the previous circuit that I had to expose the leads. With the switch open, I'm going to come and do 2 pigtails. And I'm going to try to get it so that I have the 3-volt motor and the light to go on at the same time. And I'll see. Now, we know that electrons do work and certain voltages are required to run certain materials. So this is a 3-volt motor. So what I've done here is I've created it so that the path, the electrons go through, they come through the light, they come out the light, they go through the green cable, they go into the motor, then they come out of the black, they go into the red, back to the battery. So that creates one loop. So when I turn it on, I see that the light goes on, but the motor does not. So we have a bit of a problem here. And the problem is the fact that when we have 2 load items, 2 items like the motor and the light, they're sharing electricity from the battery in series, which means that basically half the voltage goes to the lamp and half goes to the motor. The motor needs 3 volts though. And so if it's only getting 1.5 volts because the light's getting the other 1.5, the motor will not turn. There's not enough electrical work available to make that happen. So we have to do something slightly different. And that's where a parallel circuit comes in. So we turn the switch off. Now what we're going to do is we're going to carefully remove, we're going to undo the pigtails that we did before. Okay, and so we're going to take the motor completely free and we'll put it off to the side for a moment. And we're going to complete that electric circuit that we had earlier, the simple DC circuit that had just the light bulb running. And we'll check it again just to make sure. Sure enough, there goes the light. So we're going to turn it off. Now, in a parallel situation, what we're going to do is we have this open wire lead and this wire lead. So we already have one loop. We're going to create a second loop. And the second loop is going to be the motor pieces. So I'm going to put one end of the motor piece on one of the connections. So I'm going to create a 3-way connection here. And so you got to be a little bit patient to wrap that copper around, make a good connection. So there's a good connection there. And then I'm going to go to the other spot and I'm going to make a good connection there. And so what I'm doing is I'm basically setting it up so that I have 2 loops. So half the electrons are going through the light switch, half the electrons are going through the motor. So I have 2 loops. So if I look, I've got one loop that goes through the motor. There's loop number 1. And then I have one loop that goes through the light. Now, in setting it up this way, there is 3 volts difference between these 2 wires, which means there's 3 volts going past this lamp, and there's 3 volts going across my motor. And so if I flip the switch, you're going to see that the motor starts to vibrate, it bounces around. But you're also going to see that the lamp doesn't turn on as brightly as before. And that's because now we're keeping the voltage high, but we're splitting the current. We can't use as much current. And I'm going to show you, I'll just slowly remove one of the leads. Oh, that's not the one I wanted to lead. I'm going to take the motor mount off of one of the leads so that the motor is disconnected momentarily from my circuit. So I've removed the motor, so there's no loop for the motor. And so when I turn the lamp on, you see a really bright lamp. Now, if I take and I temporarily touch the motor back to that spot that I disconnected, you'll watch that and I'll be quiet and you can hear it. The motor starts to vibrate, but it also shows the light goes dim because now the electrons are going through, half of them are going through the loop with the lamp and half are going through the battery. And so it bounces around, and in fact, it already bounced it right off the connector, so it stops. So anyways, that's a parallel circuit, and one of the reasons why you use